Day 7 video, equivalent expressions. Another name for this is called literal equations. And what we are doing today is we are solving for one variable. And there might be more than one variable in that equation, and so you solve for one of them. So you basically do the same inverse operations, but we're going to apply them to variables instead of just numbers. We can use number properties, especially inverse operations, to rewrite formulas and equations. Use inverse operations to solve the equations for the unknown variable, or for the designated variable if there is more than one. If there is more than one operation to undo, be sure to think carefully about the order in which you do them. For equations with multiple variables, it may help to first solve a version of the problem with numerical values substituted in. Make sure to write the number property you used next to each step. Okay, so 5 equals a minus 3. You want to solve for a. You want to get a alone. Okay, so I'm going to highlight the a so you know that's what you're getting alone. Right now, with the a is a negative 3. How do you get rid of a negative 3? You add 3. And so you get 8 equals a. The number property that you just used was taking a negative 3 and canceling it out, or adding the inverse, in order to get 0. When you do the additive inverse, you get 0. So this number property is called the additive inverse. You cancel out to get 0. The multiplicative inverse is when you get 1. The additive inverse is when you get 0. So that was a problem with numbers. This, number 2, is a problem with letters. It's the same exact problem, a minus b equals c, but instead of c, I put in 5. Or I'm sorry, instead of 5, I put in c. Instead of b, I put in 3. You are going to get this alone with a being the one where it's alone. So I'm going to show a is what I'm not touching. A is what I'm leaving alone. That's what I'm getting alone. Negative b. How do you undo negative b? You add b. You add b. Cancel. And you get a equals c plus b, which is really what you had over here. You had 5 plus 3 and you got 8. You can't add c plus b, so you just have to leave it as c plus b. And again, you did the additive inverse. Negative b plus b gave you the additive inverse because they canceled out to give you 0. Alright, well what if it was multiplying instead of subtraction that I was dealing with? I times r. Actually, I'm going to do the one with numbers first. I'm going to do number 4 first. X divided by 5 equals 3. You have x being the variable, so you can't touch that. And you want to remove that 5 somehow. How are you going to remove that 5? It's being divided, so you are going to multiply it. Okay, so when you do that, these cancel. To get 1, that's important, because that's called the multiplicative inverse. You multiply by something to get 1, and you get x equals 15. Multiplicative inverse. Alright, number 3, I times r equals v. Solve for r. Same thing as number 4, but with all letters. You have I being multiplied by r, so how do you undo multiplication? You do some division. This is also the multiplicative inverse, because I divided by I gave you 1. And you wanted to get 1, r, because that meant that r was alone. V over I. 5, solve for a. W equals a divided by 3. This is what you can't touch. This is what you want to get alone. You are being divided by L, so in order to undo that, you want to multiply by L. And you multiply by L because L divided by L gives you 1. So again, that is the multiplicative inverse. Okay. And then you will see for number 6, a two-stepper. All of these so far have been just one step. Number 6 is a two-step, but it's a two-step with all numbers except for that variable x. So you've done this many times. You put your line, you draw a circle around your variable and your coefficient, and you minus 3. What is the operation that you are using to cancel out the positive 3? You are doing the additive inverse to get it to cancel out to be 0. And so now you get 7x equals 7. And then you want to get 1x. So you're going to divide by 7 using the multiplicative inverse to get 1. The reason why it's called the multiplicative inverse when it looks like you're dividing is because dividing by 7 is the same as multiplying by 1/7. So we still call it the multiplicative inverse because you can think about dividing by 7 in terms of multiplication too, multiplying by 1/7. Number 7 has the same problem as number 6, except for instead of a 7, I'm using an A. Instead of a 3, I'm using a C. Instead of a 10, I'm using an R. So I want to get x by itself. I'm not going to get a number. I'm going to get an expression with all these variables involved. All right, wanting to get x alone. Line, circle. First thing you do, you want to get rid of the C by subtracting C. This is going to look different. I don't know what r minus c is, so I'm going to literally write the answer here is r minus c to what a times x equals. Okay. Next, a being multiplied by x. To undo that multiplication, you do division. I don't know what r minus c is, and I don't know what r minus c as a quantity divided by a is. So your answer is x equals r minus c divided by a. And steps that you have taken in the beginning, we've done the additive inverse to cancel out the c with a negative c, and then you did the multiplicative inverse to get 1x. You multiplied a by 1 over a, or a divided by a. Number 8, 2h equals w minus 3p. It is a two-step, but instead of adding a 3 or adding a c, I'm subtracting, and I've switched the order of the coefficient with the variable with the constant. So I'm going to circle this. You can't touch the coefficient with the variable. So to get that alone, you are going to get rid of the w by subtracting w. Get rid of a positive w, subtract w. I don't know what h and w are, so my answer is 2h minus w equals 3p. Okay, and then 3 times p, you're going to divide by 3. And you divide that whole side by 3. Don't just divide the 2h by 3. Make sure you divide the whole 2h minus w by 3, that whole quantity. Your answer is p equals 2h minus w divided by 3. You did the additive inverse and the multiplicative identity again for that one. All right, lots of variables here. Solve for g. F equals g times m times n divided by r squared. All right, starting out. Let's get rid of that r squared first. How do you get rid of dividing by r squared? You multiply by r squared. And that is called the multiplicative inverse because it's r squared times 1 over r squared. All right, r squared times f equals g times m times n. All right, you want to get g alone. M and n are both being multiplied by it. So if you divide both m and n, you will get g alone. And so your answer is g equals r squared. I don't like it when it puts my equal signs like together. I like them to be separated. R squared times F over MN. And those are all legal moves. Dividing by M and N and multiplying by R squared. Legal moves. All right, solving for C. This is an interesting one because we have done this last year, but I don't know if you remember it. C is being multiplied by 9/5. So, there's a couple options. It's a coefficient. You can divide by 9/5. Now, the problem with that is that when you, don't write this down please, when you've divided by 9/5, you have now a fraction within a fraction. Okay, so then you have to undo that. You don't want to have a fraction within a fraction. So what we do, to avoid using a calculator, because when you divide by 9/5, you probably need a calculator, we multiply by the reciprocal so that these 5 cancels, these 9 cancels, and you have 1C. The trick is that you have to multiply the whole F plus 32 by 5/9. Because if you're multiplying just one part of it by 5/9, you are not getting the whole quantity. This is the formula to convert Fahrenheit to Celsius. You have a Fahrenheit number, and I mean we had to do this in Italy over the summer because they would say it's like 20 degrees outside. So what does that mean? It means that 20 degrees is the Celsius amount, and you have to do the conversion to Fahrenheit. This particular one you have right in front of you, if I give you a Fahrenheit amount, say I give you 80, you'd plug it in for F, so 80 plus 32 gives you 112, and then you'd multiply 112 times 5/9. Let's do 112 times, and then 5/9 is 0.55555, repeating, and so you get 62. 80 degrees is 62 degrees Celsius. So here's a good question. Why would it be difficult to solve for x when it is 3x minus xy equals m to the 4th? I'm going to do a dual page here so you can see the difference. The other problems, whenever we were solving, there was only one A in number 1. There's only one A in number 2. There's only one R in number 3. There's only one X in number 4. There's only one A in number 5. There's only one X in number 6. There's only one X in number 7. There was only one P in number 8. There was only one G in number 9. There was only one C in number 10. The variable that I was trying to solve for, there was only one of them. The difference between all of those and number 11 is X appears twice. It's very hard to get X on its own, when there's 2 of them. How are you going to get both X's alone? And so that's the problem that arises here. It is difficult because X appears twice in the equation. So we cannot get X alone with what you know right now in 8th grade math. Are the 2 equations below the same? Explain why or why not and justify using algebra. Alright, so I have negative 3x plus y equals 2, and I have y divided by 2 equals negative 3 halves x plus 1. I'd like you to move some things around to try to get them to look the same using your number properties. Go ahead and try that right now. Pause the video, try that right now, and then unpause to see what I get. Okay, so when I work on this, I'm like, all right, I want to get something alone. It doesn't matter to me if you get x alone or y alone, to show that they're the same. But it looks like y is already, there's no coefficient in front of it here, so I'm going to try to get that y alone because it's easy to do. I just have to add 3x. And I have to add it so it looks like a plus sign. All right. So I get, using the additive inverse, I get y equals 3x plus 2. All right. So now, if I get y alone on the other side, I should get 3x plus 2. All right, well, how am I going to get y alone? I have with y a 2. It's being divided by 2. So the best way to get rid of that 2 is to multiply it by 2. Whole side to get y alone. So you get y equals, this is negative 3 halves times 2. So I'm going to kind of go to the side. Negative 3 halves times 2 over 1. You cancel. And you get negative 3x. And then you have plus 2 times 2, and that's going to be a plus 2. So what I just did is I distributed that 2 to both the inside terms. Are they the same? Well, you have a plus 2 here. I'm sorry, that's not where I want to highlight. You have a positive. There we go. You have a positive 3x here, and you have a negative 3x here. So, no, they are not the same. The coefficient on the x is what is different. The coefficient on the x is what is different. Oh my goodness. This pen is really hard for me to write with. Okay. Solve for D. P equals parentheses x plus 2d times k minus 7 in parentheses. In order to get D alone, I would first get rid of the other parenthesis and then work inside that parenthesis. So if you know that x plus 2d is being multiplied by k minus 7, I would first, and that was my hint to you, I would first divide by k minus 7 using that multiplicative inverse. Okay, so your first step is p over k minus 7 equals x plus 2d. And I got rid of those parentheses around the x plus 2d because now that it's not being multiplied by k minus 7, you don't need them over there because it is alone now already. Well, kind of keep going away here to try to get this d alone here. First, I didn't want to touch this whole thing. Now I really just want to not touch the piece that's directly with the d, the 2. So I'm going to first subtract by x, and I'm going to go over here, and I get p divided by k minus 7 minus x equals 2d. And then the last step is to divide by 2. This is kind of annoying because it's this whole thing divided by 2. So it's this whole big answer, p divided by k minus 7 in parentheses minus x, that whole thing divided by 2. This is a difficult problem. Good challenge problem. All right, last but not least, are the two expressions below the same? Explain why or why not, and justify using algebra. I took this off the test that I gave you guys last year. So I'd like you to try this problem. And then I will check this specific one when you come in tomorrow and see how you did. You can use algebra here, and then here I'd like you to show that they're the same, substituting a number in for n. So if you substitute some number in for n, you should get the same answer for both if they are, in fact, equivalent expressions. All right, I'm checking number 14 tomorrow, and I am finishing with 30 seconds left. Don't you think I'm awesome? Yep.